This is the first in a series of videos on graphing exponential functions. So first of all, in this one, let's focus on simple functions of exponential growth of the form y is equal to a b to the x, where b is greater than 1. So if b is greater than 1, we know it's an exponential growth function. And though we'll have more complicated functions later, in this case all the graphs are going to be pretty straightforward. And the first thing you're going to notice is the starting value is a. And when we graph that on an xy graph, what we mean there, right, by the starting value is that x is equal to 0. So when x is equal to 0, the way you find y is you simply plug it in. So you go y is equal to a times b to the x, plug in x equals 0, a times b to the 0, b to the 0 is just 1, so that's y is equal to a times 1, or y is equal to a. So in other words, the starting value is exactly the same thing as what we call the y-intercept. So in these simple problems, at least, the y-intercept will always be the point 0, comma a. As an example, let's say y is equal to 10, 1.5 to the x. Then the y-intercept would be the point 0, comma 10. The second thing about exponential growth functions is exponential growth functions have what's called an asymptote. And what the asymptote is it's going to be a vertical line y is equal to 0. So the general form of the graph is going to look like this. This point right here is going to be 0a. It's going to grow in this direction and decline in this direction, but it's going to get closer and closer to the value of y is equal to 0, so we just say the asymptote is y is equal to 0, and that's the general form of the function. And the key here is that you can just memorize this. Whenever you have a simple exponential growth function that looks like this, you will always have an asymptote y is equal to 0 every time. Let's memorize that. And the third step is you're going to find out the rest of it with the table of values. So if you want to think about steps, your very first step, when you notice that it's of the form y is equal to a b to dx, this exponential growth function of a simple form, the first step is to find the starting value, or the y-intercept. The second step is to define the asymptote. And the asymptote is always the same, so that's easy. And the third step is to do the table of values. So let's look at an example. And to start off, let's look at the example. Let's graph y is equal to 1/2 times 4 raised to the x. And your first step is to find the y-intercept. At the y-intercept, x is equal to 0, so you plug in x equals 0, and you get y is equal to 1/2 times 4 raised to the 0. But 4 raised to the 0 is just simply 1, so you get y is equal to 1/2. Or I like to say it, the point 0, comma 1/2. So if you think about a simple graph, we'll graph this in a second more formally, but at first, this is your first point right there, 0, 1/2. The second step is to find the asymptote. And though later the problem will get more complicated, the asymptote is pretty straightforward. The asymptote is a line, y is equal to 0. And sometimes we write that as a dotted line, but since we have colored paper here, we're going to write the asymptote. We're going to put the asymptote into pink. The asymptote is y is equal to 0. It's not part of the graph, it's an attribute. And the third step is to make a table of values. And to make the table of values, You can use as many as you like. Probably 5 would be plenty. I like to put the y-intercept in the middle. The y-intercept is 0, 1/2. And now what I'm going to do is I'm going to choose 2 points that are larger than 0 and 2 points smaller than 0, 2 values of x. And I'm going to choose the values 2 and 3, -2 and -3. Now, when we're doing parabolas, you want to make sure that these are equally spaced, and in this case it's not important. And now what you do is once you choose the x values, you find out the y values, and you simply plug it into the formula. So the formula is y is equal to 1/2 times 4 to the x. So I'm just going to plug in 2, so that's 1/2 times 4 squared. 4 squared is 16, so that's 1/2 times 16. 1/2 of 16 is 8, so that's 8. And then you're going to do 3. 1/2 times 4 to the third. 4 to the third, let's do that in the calculator real quick. That's 4 raised to the third times 1/2, or 0.5. I get 32. Then you get -2. Now remember what negatives mean. That's 1/2 times 4 to the -2. So let's think about that. 4 to the -2 means 1 over 4 squared, or 1/16. So that's going to be 1/2 times 1/16, or 1/32. So it's essentially 0. And then you have y is equal to 1/2 4 to the -3, which is 1/2 times 1 over 4 to the third. If I plug that in the calculator, that's 4 to the third. 64 times 2 is 128, 1 over 128. And these are cases where, since you're graphing it, you probably want to do decimals. 1 divided by 32 is 0.03. 1 divided by 128 is equal to 0.008, more or less. Now these are so small that on a graph you're not really going to be able to see them. So let's review the steps first. The first step is the y-intercept. The y-intercept of this problem. This problem is right here. The y-intercept is 0, 1/2. The second step is to find the asymptote. The asymptote is y is equal to 0. And the third step is to do table values. And the fourth step is you simply plot them on a graph. Now the difference between graphing this and graphing a lot of other things is the numbers here get so large so quickly. A lot of times you're not going to really be able to do it on graph paper. We can get a good sense. Let's get a straight edge. Draw an XY graph. X and Y. Plug in some points. Now the first thing I'm going to do is plot the y-intercept. That's this point right here. I'm going to plot these in blue. So that's the point right here. That's the point 0, 1/2. Then I'm going to plot the asymptote. The asymptote is going to be a horizontal line. I'm going to draw this in pink. Typically on a graph you often do it as a dotted line, and you label it. I just label it ASY colon y is equal to 0. Everyone's going to know what I mean there. And then I'm going to look at my table of value and I'm going to plot these points as well as I can. So -2 is practically 0, and -3 is even closer to 0. So if you look at that graph is going to look something like this. Right? Get really flat there. Then I have the point 2. 2 is going to be 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. we could just see on the graph, that's the 0.28. And then the next graph we're not going to see. So this is going to come up like this and go like this and like that. And then there's another point there. That's going to be the graph. Y is equal to 1/2 times 4 to the x. And that's generally going to be the case when you graph these. Is that it's going to be really flat and then get really steep. Let's do another example. And this time, let's graph y is equal to 8, 1.15 to the x. Now here, since it's a decimal like this, you're definitely going to have to use a calculator for this. So in this case, what we're going to do is the first step is we're going to find the y-intercept. The y-intercept is the 0.08. The second step is we're going to find the asymptote. The asymptotes here are all straightforward. They're all y equals 0. And the third step is we're going to do a table of values. I'm going to put the intercept in the middle. And that's going to be 0, 8. I'm going to choose any 2 points here. I'm going to choose 2 and 5, minus 3 and minus 6. I'm going to do these on the calculator real quick. So you get 1.5 raised to the 2, and then times 8. And I get 18. So let's just think about how I did that. That's y is equal to 8, 1.15 raised to the 2. I'm going to plug this in my calculator. I'm going to do this part first, 1.15 squared, 1.15 raised to the 2, and I get 1.3225, and I'm going to times that by 8. And I get 10 point, I read that wrong, it's about 10.6. So let's say 10.6, and let me do that with the other ones real quick. 1.15 raised to the 5 times 8. I get around 16.1. 1.15 raised to the -3 times 8. I get 5.26, and you get 1.15 raised to the -6 times 8, 3.46 or so. And then what you're going to do is you're going to plot those points, right? So let's do a quick XY graph. Always use a straight edge. And here what you're going to do is you're going to do 0, 8. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8. Do 0, 8 first. Then you're going to do the asymptote. The asymptote is going to be y equals 0. And then the other points here are going to be 2. 1, 2 goes up to about almost 11. That's 8, 9, 10, 11, not quite 11. And then 5, 2, 3, 4, 5 is going to be up here at 16, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's probably off the graph there. It's going to look something like that. And then you have -3, 5.26, a little bit past 5, -6, a little bit past 3. Now here's where you get the idea of the asymptote. You know this is going to come down. It's going to go through those points, and then it's going to get closer and closer to the asymptote but never reach it. So this is basically what your graph is going to look like. And you're probably going to want to label some of these points. 0, 8 to 10.6 minus 3, 5.3. And you have your asymptote. And that's how you graph exponential functions, exponential growth functions.